video is just strictly for checking to make sure that we know what we're doing on some of these quotient problems involving exponents. So again, if you look at these two problems, we're just going to go through and go through them and figure out if we know how to do them. But there is a difference between these two problems. This one down here has numbers, and this one doesn't. If we do deal with a problem that has numbers, that's okay. You're just going to take those numbers separate, basically. But this one doesn't deal with numbers, so we can start here. The A and the B are separate. So let's talk about the A's first. What exponents do those A's have? Well, this one has a 7. This one technically has a 1, and they're being divided. If we have common bases, and we're dividing, what do we do with our exponents? That's just a rule that you got to remember. We have to subtract them. So 7 minus 1 is 6. So this will be a to the 6th. And again, I'll erase this so we can see it a little better. But I just took 7 minus the 1 that's really there. 7 minus 1 is 6. Let's move on to the b's. We have b to the 6th divided by b to the 4th. If we subtract those exponents, we will get b to the 2nd. And again, I just took 6 minus 4 to get 2. We can't simplify that one anymore, so that is our final answer here on that first one. Moving on. We are going to simplify here. I have 5 over 25. I have to start with the numbers here. So I like to just draw, especially when it looks crazy like this one, I just like to draw a big division sign and just throw things on there once I get to them. So 5 over 25 is the same thing as 1 over 5. And I have a lot of people make that mistake where they say 5 divided by 25 is 5. But it's actually 1/5, as you can see that I've written it. That's 1/5. Now we're going to move on to the y's. We have y to the 6th and y to the negative 2nd. Now some of you might get tricked and start thinking about doing like the x since it's right below it. But I had to find common bases on that. These are both y's, both of the ones that I've highlighted, so I've got to use both of those. Y to the 6th and y to the negative 2nd. This is the first time we have actually seen one of these where we're going to have to subtract when we have negative exponents. If I'm subtracting this, I'm going to have to take the 6 minus a negative 2. 6 minus negative 2. Remember when you have two minus signs together, you can call it keep, change, or adding the opposite, whatever you want to think about. But 6 minus negative 2 is actually a positive 8. So my y value, and again, when you subtract them, they always go on top, whether they're positive or negative. Immediately after you subtract, it has to go on top. We have 6 and a negative 2 making a positive 8 when we subtract them. Then we've got to move on to our x values. So my x value here and my x value here, common bases, we're dividing them. We're going to have to subtract exponents. Let's do that. Negative 9 minus negative 8. That's tricky. If you need to use a calculator, you're more than welcome to. But when you have two negatives together, they become a positive. So negative 9 plus 8, well, that's just equal to negative 1. So x to the negative 1, like I said, put it on the top first. They always should go on the top when you're done subtracting. Then we can kind of fix it up and make it look better. We don't really need the 1 there. There's no need for a 1 to be multiplied by the y. And then we'll be left with y on the top to the 8th power. That doesn't have a negative exponent. But this one does have a negative exponent, so we're going to have to move it to the bottom with that 5. 5 will just stay there because it doesn't have a negative exponent. And then x will have a positive exponent of 1 down there, which I'm not going